Hi everyone, I'm Mimi Edusewa and I'll be taking you through regression analysis using the search method. In this presentation, we are going to estimate the regression coefficients through searching in the data, and then we are going to predict the Y outcome by searching in the data. So first of all, what is regression analysis? Regression analysis is a statistical method used to examine the relationship between one or more independent variables and a dependent variable. It helps in understanding how the value of the dependent variable changes when one or more independent variables are varied. Now we have an idea on regression analysis. Let's look at what search method in regression analysis is. So it is a method of variable selection in regression analysis, and it systematically explores different combinations of predicators to identify the subset that maximizes predictive power while minimizing overfitting. And usually this technique enhances model interpretability and efficiency by focusing on most influential variables. One may ask, why search method in regression analysis? So firstly, it solves a major issue with the present mode of reducing sum of squared residuals. Usually, regression through search streamlines regression analysis by addressing a key issue, which is the need to specify interactions, terms, and the model form before fitting the data. Traditionally, this approach has been effective, but with high dimensional data, and it becomes impractical to specify all interactions and model forms accurately. Regarding the last mile problem, this is a central challenge in languaging models. Usually, these models rely on prompts and completions to infer knowledge from their vast databases. However, when multiple prompts are relevant, language models may produce inconsistent inferences, which leads to this issue called last mile problem. And the search technique described resolves this issue by consistently identifying the most relevant prompts and optimizing the AI's inference process. This in all enables more reliable and coherent reasoning based on the example cases within the model's knowledge base. Okay, now that we have an idea of what the search method is in regression analysis and its importance, let's look at what requirements will make this technique viable. So first of all, you would want to transform the independent variables, and you do so by starting to ensure that they should be scaled from 0 to 1. Usually, if this condition is not initially satisfied, the maximum or minimum transformations can be applied to ensure all variables fall within the required range. Additionally, it is crucial that all independent variables exhibit a monotone characteristic and a positive relationship with the outcome variable y. The second vital requirement is to ensure no order violations. Now, order violations occur when the order of the outcome of y between two cases switches due to a shared feature. So for instance, if you want to consider three independent variables a, b, and c, when only a is present, the outcome y is lower than when only b is present. However, when a shared feature c is added to both cases, the outcome order reverses. Now, the cases where the feature a has a higher y value than the case with feature b, this is a phenomenon known as the order of violation for shared features and cannot be captured by the usual, or let's say the traditional regression or mathematical models. Instead, such cases must be treated as exceptions to general model. In the search approach, we repeatedly utilize this feature to identify and address order violations, ensuring a more accurate analysis. Now on to our question 2. It says here in the following, Y indicates the logit of probability of an outcome, and it is regressed on x1 through to x4. All variables are binary, all independent variables are monotone, and all are related to y. Now, y values are standardized so that when all independent values are absent, logit of y is 0, and when all are present, logit of y is 1. Using the technique of searching the data to construct approximate regression equations, answer the following questions. So we can see that values here are have viable characteristics. So in looking at question 1 of 2, what is the coefficient of x1 in the regression of y on x1 through to x4? Now looking at the coefficient of x1 in the regression of y on x1 through x4, here we have the column x1 whereby all values from a to h have a value of 1, and then values of I to p are 0. Note that values from x to 4, values in x all the way to 4 have the monotone, binary, and positive y outcome characteristics. So here we are going to use a mean arithmetic equation to get this coefficient, and we do that by starting with individual subtractions of a minus 1, b minus j, c minus k, and then d minus l, and then e minus m, f minus n, g minus o, and then h minus p, all summed up, and find the mean over 8. Question 2 states, what's the coefficient of x1, x2 in the regression of logit of y on x1 through x4 plus all possible interactions among independent variables? Now, first take note of the first part of the statement, x1, x2, which are these two columns, since we are considering all values here. On the regression logit of y on x1 through x4 plus all possible interactions among independent variables. So if you are looking at the x1 and x2 values as a compound, ranging from a to d, you have both values of x1 and x2 being 1. Now, from e all the way to h, all values of x1 are 1, but that of x2 is 0. Looking from I all the way to L, all values of x2 are 1, and that of x1 is 0. But from M to P, you have all values as 0. So now we are looking at the subtractions all combined in a sum to find the mean by dividing it by 8. So you have A minus G here, B minus H, we have C minus E, D minus F, I, continuing here where x1 starts from 0, you have I minus O, J minus P, K minus M, and then L minus N. You sum all of these subtractions up, and then you find the mean by dividing by 8. Now to get an exact specification of regression coefficient for x1, what do we need to do? It's in 4 major steps, whereby we start by collecting all actual values of y and not just frequencies. We then continue to include all possible interactions among independent variables, that's from x1 all the way to x4 in the model. And then we run a multiple linear regression analysis with y as the dependent variable and x1 all the way to x4 and all possible interactions as independent variables. And then we extract the coefficient of x1 from the regression output. So here you can see how you have x1, x2, x3, all these products, x4, and then moving on to a compound product of x1, x2 with b1, x1, x3, x1, x4, x2, 3, all the way to b2, 3, 4, x2, 3, 4, b1, 2, 3, 4, x1, x2, x3, x4. All these products look at this particular prerequisite here, or this condition here, which states that all possible interactions as independent variables. So in looking at all these products, you sum them up, and then you'll be able to get the exact specification of regression coefficient for x1. For further studies, these are my references. Thank you.